Hi everyone, here's one more short video on section 16.6. But I do just want to begin by just reminding everyone that the big theorem was f inside k is called Galois if any of the following conditions hold. Okay, A. And again here, G equals ought K over F. Okay, order of G is equal to the index of K over F. Or KG equals F, or K is the splitting field of some f of x in f square bracket x. Alright, so we proved this in a previous video, but this is so important I want you to really remember it. This is our definition of Galois. This is what the book calls the definition, but you could take this to be the definition or this to be the definition. Any of those can be the definition. They're all equivalent. Okay, so what I want to talk about now, and this is again just to help you understand some of the book's language, we're going to talk about another theorem in the text. Okay, let K over F be a Galois extension. And we're going to let G of X be a polynomial in F of X. Suppose the roots of G that are in K are beta 1 through beta R. Oh, I'm sorry. Let's suppose G splits in K. And its roots. Hey Ben, can you close the door? Okay. So we have this set up. And we're going to again let G equal ought K over F. And at this point, we can also call it G of K over F because it is a Galois extension. At least that's what some books do. They only use the G or the gal of K over F when the extension is Galois. Okay. And these are not really theorems almost, but they're just observations about what we already know. G acts on beta 1 through beta R. Okay? And there's really nothing to prove here. G is just going to, they're just going to send those elements to each other. Suppose G, or suppose K is the splitting field of G. Of G of X. In other words, K is actually equal to F adjoin beta 1 through beta R. Then, okay, I'm just going to explain what this terminology means in case you read it in the book. Then the action of G on beta 1 through beta R is faithful. Okay. Faithful just means if faithful just means that if sigma of beta I equals sigma prime of beta I for all sigma sigma prime in G, or I'm sorry, not for all. This is for all BI, and for some sigma sigma prime in G, then sigma equals sigma prime. Now this, again, this is quite easy for us to see in our case, because if K is the splitting field of G of X, and so K is f of B1 through BR, then an action of sigma is completely determined by where it sends the BI. So if I know where it sends the BI, then I completely know what sigma is. So sigma BI equals sigma prime BI for all I definitely implies that sigma equals sigma prime. So there's nothing to prove there. Okay, our next theorem is if G is irreducible, then, so if G of X is irreducible, then the action of G is faithful. And again, oh, sorry, not faithful. It is transitive. Okay, if G of A is irreducible, then the action of G is transitive. Again, transitive is a word about group actions. So we call G's action, transitive if any element can be sent to any other. Can be sent to any other. I.e., for all BI and BJ, there exists a sigma such that sigma of BI equals BJ. That's the definition of a transitive group action. Okay, so we need to prove that if G of X is irreducible, even if K is not the splitting field, then the action of G is transitive on the roots. Now, the idea is we can form so here's the proof sketch of C. We can form how about B1 through BL, and let's say this is the orbit of B1, and we're just trying to show that L is all of the different roots. Okay, that B1 through BL is everything. But let's just say we're going to start with B1 and we're going to see everything we can hit from B1. Now we know from our previous work that X minus B1 through X minus BL, this polynomial is in F adjoin X, because the coefficients of this polynomial are symmetric elements, are symmetric under the action of g. So we know this product right here is in f of x. It has b1 as a root. So, and it's also irreducible. So, b1, so it must be g of x, which is the minimal polynomial for b1, or beta 1. It has beta 1 as a root, it's irreducible, so it must be g of x. So, beta 1 through beta L is actually equal to beta 1 through beta R, i.e. we found all the roots. And the action of g really is transitive. So remember, there are some key words we learned today. Today's lecture was brought to you by Faithful and Transitive. Okay. I will talk to you later today, I hope. Bye.